Hello, everyone. Thank you for joining us this afternoon. My name is Tracy Hartledge, and I'm the sales representative and project coordinator here at Chiral Technologies. Welcome to our webinar, Protecting Your Chiral Columns for Optimal Performance. Presenting today is Dr. Weston Umstead, Technology Manager for Chiral Technologies. Dr. Umstead graduated from DeSales University in 2011 with a BS in Chemistry and Biochemistry. In 2016, he graduated from the University of Denver with a PhD in chemistry and joined us here that same year. As technology manager, Dr. Umstead is responsible for new and emerging technologies and manages our core technical team, who are responsible for our in-house chiral screening and separation services. Before we begin, just a few notes. During the presentation, you will have the ability to submit questions to our technical team via your webinar screen, or you may email questions@cti.dicel.com. In the handout section of your menu, you'll find a copy of this presentation along with information on our column selection service. Enough from me, Dr.
All right, thank you, Tracy. Good morning or good afternoon, everyone out there. I appreciate you taking the time today to check in and see what you might learn when it comes to protecting your chiral columns for optimizing their performance. Now, I will, as a precursor note to this presentation, let you know that a lot of what you're going to hear might be similar things to what you've heard before when it comes to most chromatography columns, because the reality is a lot of the issues that face chiral columns is the same for C18A chiral columns, medium pressure chromatography columns, but there is a section at the end, actually dispersed all the way throughout this presentation, that are specific to chiral columns, and I'll kind of highlight those as we get there. But if we take the main issues that most customers face when it comes to chiral columns, the biggest one we often see is pressure issues. So that will be a section that we deal with. The second one's peak shape issues related either to chromatography or actually issues with the columns, as well as retention or selectivity issues. So we'll kind of deal with those three sections as the major talking points today. And then at the end, a section on how we can help you if you are facing these issues directly related to the columns, what kinds of services we have that might be able to restore the function, or perhaps you might actually need a new column. So we'll start with pressure issues. So what causes pressure issues? Primarily, it's going to be some kind of a blockage within the system. And blockages within the system sometimes can occur elsewhere, but most times it's because there is a plugged inlet frit. Now, the inlet frits get plugged from a number of different reasons. So there's some kind of particulate matter, though, that's building up that's causing the pressure to spike. It can either be some kind of an insoluble material in the sample. It could be some particulate coming from the wearing of your pump, the pump seals, or the rotors. There could be some mobile phase incompatibility issues with sample solubility. So for instance, you have your sample dissolved in 100% ethanol. You go and inject it on the column with a mobile phase that's high in hexanes, 90-10, for instance. And sometimes we'll see the sample actually crash out because it's not soluble in the hexane. There can also be some mobile phase component crashing out inside the column. So if you've got a buffered aqueous system, for instance, the salt can sometimes crash out inside the column. And then in your aqueous columns, your aqueous mobile phases, again, there can be some bacterial growth as a result of not using the column frequently, or some bacteria that's in the mobile phase that has contaminated the column. So how do these issues, a blocked inlet frit or a plugged inlet frit, how do they generally manifest themselves? We normally see it resulting in split peaks. So this is an example from a review article from John Dolan in the LCGC magazine back in 2008. So in this particular case, this was a sample that was injected on a column that had a blocked inlet frit. So you'll see relatively symmetrical doubling of the peaks, or if you were to run a clean analytical standard, again, smooth baseline, but doubling of the peaks. You could also see it manifesting itself in some severe peak tailing, as in this particular case here, or in maybe not as obvious of a case, you might actually see a shoulder in the backside of the peak. And these make sense when you look at what exactly is happening on the column as a result of a blockage within the inlet frit. So in a perfect column case, so your inlet frit's not blocked at all, your analytes are coming through the column in one uniform flow. But if you end up blocking the inlet frit with some kind of particulate matter, you've got a portion of it that's coming through at one rate, and then another portion that's going to be coming through at a second rate as a result of that blockage. So you've got your normal flow as kind of your major peak in this example, and then the shoulder coming through as this portion that got hung up as a result of the particulate. So what happens? It's blocked. How can you diagnose this issue? How do you know for sure that it's a blocked inlet frit? There's a test that you can kind of do that sometimes works. It's not 100%. You could still see some of these issues arising as a result of either degradation of the column or some other issue. But occasionally what you can do is you can reverse the column direction and you can inject a sample. And if it's a blocked inlet frit, occasionally the chromatography will be restored. So you'll see your peaks sharpen back up. You won't see the doubling again. And if that's the case, then it likely is a blocked inlet frit, and that would make sense because the blockage at the inlet of the frit really causes the extra column band broadening throughout. So if you were to reverse the flow of the column, the splitting that occurs as a result of the two different portions coming through the inlet frit, it's not exacerbated over the whole entire length of the column. It's just the short portion that comes out from the outlet into the detector. So usually the chromatography can be restored. If it's not restored, then likely it's something else. But again, I have the caveat here that if it is not restored, it could still be a blocked inlet frit. However, the inlet frit might just be so blocked that even at the outlet, the change, the slowdown is dramatic enough to continue to show that that the split peaks. The best thing that you can do is to QC the column in the normal flow direction and compare it to the performance test chromatogram that was supplied with the column when you purchased it. That is kind of the best way to go. You'll see issues with peak shape. You'll see the issues with plate count. So that's kind of the way that we generally suggest that you diagnose this issue. How can you preemptively prevent these pressure issues from occurring? Well, if you have insoluble material in the sample, one of the best things to do, and actually this is good practice even if you don't have insoluble material in the sample, is make sure that you're filtering your sample solution and filtering your mobile phases as well through a 0.5 micron filter. Or if as you're mixing up your solution for your sample and you still see some turbidity, some cloudiness, you might need to go to a smaller micron size filter, something like 0.2 micron instead. Other sample cleanup might need to be done as well. I'll talk about that a little bit later on in the retention and selectivity section, but things like solid phase extraction or a C18 cleanup, something like that might be needed as well. If you have particulate that's forming from the pump seals, obviously the easiest thing to do, and even if you're not getting particulate forming from the pump seals, just do regular system maintenance. We do our maintenance every year here. Just as a preemptive measure, you might find that you need it to be done more often if you're running a large number of samples or if it's an instrument that has sat idle for some time. And then you can also use an inline filter to catch the particulate. So your seals are wearing. You might not necessarily think that you need any kind of maintenance, but the filter in place will obviously help catching any of that solid matter that's forming. And then if you have mobile phase incompatibility issues with your sample solubility, you can always do some kind of a, um, well, first off, make sure that your sample solvent and your mobile phase are matched to each other. This is especially important if you're scaling up to a prep scale. Not having these sample solvent and mobile phase match actually causes a lot of different chromatography issues, not just related to peak shape. It can cause some peak shape issues. The other thing you can do though is do a small solubility study to check to make sure that your sample doesn't actually crash out. A lot of times, if you're just making your sample up in the sample solvent, you let it sit for overnight or several days, you might not necessarily see something crash out, but if you are making your sample up in the mobile phase, you might find that over time it actually begins to precipitate out. So this is kind of a way to help ensure that that doesn't happen on column. Now, this next section for the column storage conditions, I wasn't really quite sure where I wanted to put this at, but I think it fits best with pressure issues because most of the time, improper storage of the column ends up resulting in high pressure, primarily because there are components either in the sample or in the mobile phase that end up precipitating out over time. So I throw the column storage conditions in here in the pressure issue. So dealing with reversed phase columns or reverse phase mobile phases first, both short-term and long-term storage are pretty much the same. For short-term, it's okay to leave the column connected to the system, but long-term, you might want to take it off and perhaps store it in the refrigerator, especially if you are using biological samples, anything that might be exposed to bacteria. Bacterial growth is an issue, as I mentioned before. But make sure that you flush the column with some kind of a mobile phase that does not have salt or buffer in it. So the idea is you want to make sure that you're removing those components as they are the primary agent in precipitating out in the column. So something like water acetonitrile, 60-40. The 40% acetonitrile should be good enough to help prevent that microbial bacterial growth. But again, like I said, if you want to be extra cautious, storing it in the refrigerator is not a bad idea. For normal phase and polar organic short term, so we're talking less than a few days, again, you're all right with leaving it on the system, but you want to make sure that you flush the column with ethanol after your analysis. This is primarily to make sure that you're removing any mobile phase additives, acids, and bases, just to make sure that it's not sitting on column, potentially having some negative effects on the stationary phase. For long-term storage, again, you're going to want to flush with ethanol for the exact same reasons. You want to make sure you're removing those potentially negative additives for storage, and then flush with 9010 hexane IPA and store it in that. It's perfectly safe then at room temperature out on the bench. If you are using your columns kind of interchangeably for polar organic mode and normal phase, or you're running your columns in polar organic mode and you obviously need to store it in this 9010 hexane IPA mixture, it's extremely important that you do the ethanol flush before you go and do the 9010 hexane IPA storage conditions, especially if you are running your samples with 100% acetonitrile or 100% methanol, because those two solvents are not miscible with the high percentage of hexane. And you can actually end up causing other negative effects to your column, pressure issues mainly because they are not miscible with each other. So this is kind of a diagram to show you the switching back and forth. Down below here, you've got your polar organic solvents, either mixtures of ethanol, methanol, or 100% ethanol, methanol, and acetonitrile. You can use something like 2-propanol or IPA as an intermediary solvent, or as I suggested on the last slide, 100% ethanol works as well. The point is, though, you don't want to go directly from acetonitrile or methanol directly to these alkane alcohol mixture for storage, because you'll find some very interesting things happen with pressure. And then lastly, we'll talk about protein column storage, less than a few days. You want to make sure that you flush the column with some kind of a mobile phase that does not contain salt or buffer, again, similar to the reversed phase columns. However, for the protein columns, because they're a little bit more sensitive to the organic concentration, we recommend that you'd flush with 90-10 water IPA as opposed to 60-40 water ACN, which is what I had recommended on the reverse phase columns. For the storage, then you want to store it in the water IPA mixture. It's a little bit different though for the different protein selectors. So for your AGP and your CBH columns, after you flush with 90-10 water IPA, you want to make sure that you flush with 85-15 water IPA, and then that is what you can store it in at ambient temperature. And for the serum albumin columns, HSA, BSA, you can keep it in the 90-10 water IPA mixture, and again, store it at room temperature is fine. For long-term storage, week or longer, same conditions as far as the flushing goes and as far as the storage solvent goes, but you definitely want to make sure that you store these in the refrigerator. 10% or 15% IPA generally is good enough to help prevent the bacterial growth. However, you don't want to leave anything to chance, so keeping them in the refrigerator kind of helps minimize that as much as possible. So what happens after you see a rise in the pressure? Well, if you have particulate that's coming from wearing of the pump seals or the rotors, you likely are going to have to replace the inlet frit because you have material now on the inlet frit that has blocked it that is pretty much insoluble to most organic solvents, or at least those that you can actually use to flush your columns with. Talking about a rubberized material or a plastic material, most of the times the frit needs to be replaced. If you're talking about a prep column, analytical columns, replacing the inlet frit's a little bit more challenging, so you might end up having to replace the column altogether. If there's some insoluble material from the sample or the sample is crashed out, there's a kind of a two-step process. The first step is reversing the flow of the column and then disconnecting from the detector, so going directly out of the column into the waste. If you do have insoluble material, you obviously don't want that passing down the line into the detector and potentially blocking the detector any more than what it might already be. And then you're just going to have to try to find a solvent that the insoluble material is soluble in. This is the challenge when it comes to this kind of a troubleshoot. The coated phases are not extremely limited, but they're definitely limited in the solvents that you can run through them. And the immobilized columns, even though they are more robust to things like dichloromethane and ethyl acetate, it still doesn't mean that you're going to be able to find something that is able to solubilize whatever it is that's crashed down in the column or on the inlet frit. So unfortunately, 9 times out of 10, I would say, you're going to end up having to replace the column anyway. Sometimes if you catch the issue early enough, reversing the flow and doing this sample solvent wash will work. But in most cases, we end up seeing, unfortunately, the column has to be replaced. So that is it for pressure issues. Next, what causes peak shape issues primarily? So as was the case with the plugged inlet frits for pressure, they can also cause issues with peak shape. And that's caused primarily, again, from the poor sample cleanup or potentially some particulate forming from the instrument. Peak shape issues can also be caused by voids in the packing as a result of either mechanical or thermal shock. And then lastly, they can be caused by chemical modifications. So if you're injecting biological samples, for instance, there can be some strongly adsorbing analytes or sample components that are causing some interesting changes in the chromatography. And column history or memory effect can also cause peak shape issues as well. Memory effect in particular has some dramatic effects with the coated phases. We'll kind of talk about that in a couple of slides from now. What we won't be talking about in this section are method development issues, so things like additives or potentially needing to optimize your additives, sample overloading, and other extra column band broadening effects that can have a dramatic effect on the peak shape as well. This is strictly related to issues with the column. So I showed this one before. This is related to partially blocked or blocked inlet frits. You can have either this peak tailing, significant peak tailing, which by the way can also be caused by chromatography issues as well, but like I said, we won't talk about those here today, or the kind of the shoulder as a result of blocked inlet frit. But you might also actually see fronting or kind of a front shoulder as a result of a void or a column collapse. And again, if we look at a diagram of what's happening in the column itself, it makes sense. You're going to have some kind of a void potentially that has formed at the inlet frit. You've got a portion that's coming through in kind of your main slug, so your main sharp peak here. Then you also have a portion that's going to be flying through much faster than the rest of it. So you have a small portion and then it comes out as a shoulder in the front. So how can you diagnose this issue? I won't spend too much time on the plugged inlet frits. Again, it's the same as it was for the pressure issues, QC the column, compared to the test chromatogram. For voids in the packing, unfortunately, there's not a really good test for that other than opening up the column and removing the frit. When you go and remove the frit, it's pretty apparent that you have some kind of a void that has formed near the head of the column. For chemical modifications, the best thing that you can do is try a different column or a new column if you have one available to you. This is kind of related to the column history and the memory effect. Potentially there was some kind of an analyte that went through that particular column that's causing the interesting chromatography that you're seeing, the interesting peak shape, that if you were to transition to a new column or a different column that has not seen that analyte before, if it's directly related to that, you might be able to see a restoration of the chromatography. If it is not related to that, or if it's some other issue that's going on, QCing the column again and comparing it to the test chromatogram will show you for sure, what it looks like versus when it initially was released from our site here. So typically for the inlet frits, again, it's unfortunately on the analytical columns, they can't be replaced. And I will point out too with the voids in the packing, they don't happen very often, but they will happen if you go over pressure or if you're using a high pH mobile phase. High pH mobile phases above 9, above 10 especially, will actually begin to dissolve the silica and cause that collapse in the column. So what are some things that you can do to prevent these issues from happening? The plugged inlet frit, again, you're talking about either filtering your sample, having an inline filter, or using a guard column to help collect anything that might be coming through from the pump wear or other things that might be crashing out. But there's definitely no good replacement for good sample cleanup. That is absolutely imperative. Even if the sample looks like it's clear and clean, it's always good to double check and make sure that you are protecting your investment in the analytical column. Voids in the packing, don't drop or hit the columns on a hard surface. It doesn't seem like it would be such a huge issue, but whack it on the bench top enough times and you will actually begin to disrupt or move those particles around inside. So take care of your columns. Don't drop them on the floor. Operating at reasonable pressures and flow rates. I know there are plenty of people out there who want to kind of push the bounds as an experimental science as to how quickly you can push your sample through your columns, but that's the number one way to cause a void in the packing is to push it beyond the recommended flow rate and going over pressure. And in particular, in prep columns, we've actually seen some cases where the customers have bent the inlet frits. And I'll show a picture on the next slide of what that looks like. It takes a lot of pressure to do that, but if you block your inlet frit and you continue to push it at a fast flow rate, it can happen. Ensure that you are properly equilibrating your column before you are switching your conditions. So if you're doing temperature experiments, or if you are changing your viscosity of your mobile phase, you're going from something that's very easy to push through the column, like 9010 hexane IPA to 100% ethanol or 100% IPA, you'll want to make sure that you do a proper equilibration so that there's not a large pressure spike all of a sudden. And then one not necessarily related to the column itself or the method, but make sure there is a quick rotation of the sample injection valve. This is not as big of an issue on the newer systems, but some of the older systems in particular, it can be an issue, especially if you're trying to inject samples quickly. Just make sure that your instrument is set up properly to avoid some of these rather large pressure spikes as a result of slow rotation of this valve. So here is a picture, as I promised, of what a bent inlet frit looks like. This actually came from an SFC column, so the pressures were a little bit higher than what you might normally see on LC or HPLC, but that bent the inlet frit and pushed that inlet frit down into the column bed and caused a major void in the column, so the customer saw a decrease in the chromatography. And then other voids in the packing around the edges here, you can see obviously little holes, which again would manifest itself in either some fronting or some poor chromatography, or even potentially a complete loss in resolution altogether. And one more example, this is very, very obvious here. You can see quite a large section of this column has been ruined as a result of column packing. This again was another column that went over pressure and pushed the inlet frit down into the column bed and caused a major void in the column. And then if we're dealing with chemical modifications, make sure again, good sample cleanup. If it's something, a highly adsorbing analyte or component to the reaction, potentially looking at something like solid phase extraction to remove that might be something that you want to look into. This was the memory effect that I was talking about. It might be a good idea to dedicate columns to specific conditions. So for instance, in our lab, we have 3 different columns for ODH, so 5 micron OD. We have one for acidic conditions, one for neutral, and one for basic. That is to ensure that any modifier or any additives that have been put through the column are only acidic, no additives, or basic. In case there is some kind of memory effect, slight changes in the conformation of the polymer, you won't see odd things when it comes to your chromatography if you do this. And then also having dedicated columns to specific mobile phases is something that we do regularly here as well. If you have coded phases, in particular, if you put them in reverse phase, they have to stay reverse phase. The immobilized columns, as I have noted down here, can go back and forth between reversed phase and normal phase. There is a process for regenerating the columns. However, even with those, we recommend that you dedicate a set just for reversed phase, just a set for normal phase, because moving them back and forth too often can end up leading to shortened column life. So whatever you can do to protect your investment is a good thing. It's a little bit more upfront cost, but long term, you're probably going to save yourself in the end. Once the poor peak shape has occurred, with the plugged inlet frits, I mentioned the washing the column in the previous section in reverse, something that you can certainly try. Replacing the inlet frit if it's a prep column, or replacing the column if it is an analytical column. Void in the packing. Unfortunately, there's only one thing that you can do, and that is repack the column with new CSP. You have to clean up the column, remove any of the damaged CSP, and then replace it with the correct amount that needs to be there for a well-packed column. I'll talk a little bit more about repacking in the help section, because that's actually a service that we can help you with. And then for chemical modifications, reconditioning or repacking the column again is sometimes an option. But if it's something where, for instance, you've run a pH mobile phase that was too high and you started dissolving the silica, you will have to replace the column at that point. The reconditioning process, something that sometimes you can do yourself, the regeneration process, if it's a memory induced or a mobile phase induced kind of change in the chromatography, there are sometimes things that you can do on your own. So this is an example of an IA column running a hexane, ethanol, a normal phase, mobile phase, and 3 sample analytes over here. The sample solvent itself actually contained methyl acetate as an injection solvent, and so over time you actually see a degradation in the chromatography induced simply by the sample solvent. But if you take the column and regenerate it through a regeneration process that we have, you can actually restore the chromatography. So sometimes all is not lost. If you do see changes in your peak shape, there's a chance that you might be able to save it. And that's something that we can definitely help walk you through. So what causes changes in retention or selectivity? I mentioned before adsorbed samples when it comes to the peak shape, because it can definitely have it manifest itself in peak shape, but things like biological samples, in particular blood samples, urine samples, biological samples like cell extracts where there's a lot of cell debris, or petroleum-based samples where there's all kinds of sticky components, things like that. These things tend to get stuck on the columns and can cause changes in retention and selectivity. And then the other section in this is chemical attack. So we'll go back to incompatible additives or solvents. Solvents, especially for our chiral columns, is a big thing to be aware of. And then either too high or too low pH mobile phases can cause issues with retention and selectivity as well. As far as method development goes, we're not going to talk about issues like scaling from smaller to larger particles or larger column dimensions. We're not going to talk about differences in instruments, and we're also not going to talk about method robustness. That's for another day, unfortunately. How can you diagnose these issues? Well, if it's absorbed samples, QCing the column, again, like we talked before with the plugged inlet frit, it's kind of the best way to go. Occasionally, you can open the column and actually inspect the CSP and see very clearly that there's something that is adsorbed to the column. I'll show you a picture of that on the next slide. Not always recommended, especially if you're dealing with an analytical column or even a prep column for that matter, because you might open it up and cause another problem that you weren't expecting. But sometimes it's very obvious that there's an issue going on. And then for chemical attack, oftentimes the incompatible solvents or the too high or too low pH, you will actually end up seeing some kind of a white powdery solid exiting the column. And that's either the silica gel that has degraded and is now coming out, or it's the polymer that has eluded and been dissolved off the surface of the silica gel. And that is one of those issues that is unique to our chiral columns, something that you should be very, very aware of. And I'll talk about solving compatibility in a couple of slides, but that is how you will that is how it will manifest itself. What are some things preemptively that you can do to avoid these issues with the adsorbed samples? Good sample cleanup again. Can't harp on that enough. Using guard columns, using inline filters kind of helps a little bit, but you will degrade those just as quickly as you will your chiral column if you're not cleaning your sample up well. So with the biological samples, you probably want to do a little bit more than just filtering it through a membrane. So you can use something like a solid phase extraction cartridge. If you have particularly sticky components that you might want to separate out, or just components that are kind of interfering with the chromatography, doing an achiral cleanup beforehand. You might even need to go into membrane filtration or some other kind of liquid extraction to remove those components that are causing some particularly negative effects. For chemical attack, make sure that you're developing methods with pHs that are higher than 2, but lower than 8 or 9, as long as you're using the correct buffer. So if you have a pH that is lower than 2, so 1, anything less than that, that will actually cause the ligands to cleave off of the surface. This is the same for achiral stationary phases as it is with our chiral columns. You can actually begin to cleave the polymer off of the surface of the silica gel. And if your pH is too high, so higher than 8 or 9, the conditions will actually begin to degrade the silica. And that is, again, the same for achiral or other chiral chromatography columns as it is with ours. Make sure that even if you are within the suggested pH range of 2 to 8 or 9, that you're not using harsh additives like HCl as an acidic additive or harsh basic additives like sodium hydroxide. We would recommend that you use for acids something like TFA or formic acid or acetic acid, much gentler on the column and much less likely to cleave the ligands or the polymer off the surface. And for bases, using an organic base like DEA or TEA if you're doing a normal phase or a polar organic method, or a buffered phosphate or bicarbonate system if you're doing reversed phase. Again, much gentler on the column, much less likely to begin degrading the silica as a result of the presence of that additive. And then the incompatible solvents. So for the coated CSPs, this is absolutely paramount that you avoid using things like dichloromethane, ethyl acetate, DMSO, THF, MTBE, and chloroform for all coated phases. And it is extremely important that if you're using a system that has both coated and immobilized columns on it, and you're planning on using any of these solvents on your immobilized columns, that you flush the system extremely, extremely well. In our case here in our lab, we actually have dedicated systems. We call them the extended range solvents. That would be hexane dichloromethane, hexane MTBE, things like that. That system never ever sees coated phases, just as the precaution so that there's never any chance whatsoever of those coated phases seeing these solvents. They are okay with the immobilized columns, but make sure absolutely that if you're going to use the same system that has these extended range solvents on them and you're going to use a coated phase at some point, that you flush very, very well. So make sure that you flush the HPLC unit with some kind of a compatible solvent as you're switching over. So something like 2-propanol or ethanol, making sure, of course, here that your column is completely removed at this point. So you're flushing everything really, really well with isopropanol or ethanol. And then before you even put the column on, flush the entire system with the column storage mobile phase, so hexane IPA. Again, you're just trying to make sure that there's no remaining forbidden solvents in that system before you go and you put your coated phase on there. Now, I mentioned the picture about the adsorbed samples. Here is what that would look like. So this was a semi-prep column. We took the inlet frit off. This CSP is supposed to be white. And this was a case where they were running some kind of a dirty sample through, and now the CSP is nice and brown as a result of whatever the sample components were adsorbing to the column. And so we took this column in-house, opened it up and saw this. And of course, what we would do in this case is likely repack the column with new CSP. And that is something I will discuss in the help section. Again, that's something that we can help you out with. So what happens after the retention or the selectivity changes have occurred? With the adsorbed samples, I mentioned the repack. That's something that we can help you with, repacking with new CSP. But like with the pressure issues and with the peak shape issues, sometimes you can regenerate the column or you can flush the column and actually save it. Really, it just depends on the sample. It depends on the individual case. For chemical attack, unfortunately, if you have degraded the silica or you have lost the polymer off the surface, you have to replace the column. There is no coming back from that, unfortunately. So again, that's why I harped on it as much as I possibly could. No forbidden solvents on your coated phases, and make sure that you're not using those harsh additives. So now that I've covered all of those major issues, hopefully I haven't scared you too much. The chiral columns are quite robust, the mobilized phases as well as the coated phases, as long as you take care of them. It's no different than any other column. You want to protect your investment. But what happens if you need help from us? And these are things that we offer, extra services that we offer that might be able to save your column, add value to your column, and potentially extend the column life a little bit. So we do column hardware replacements. This is only for prep columns. As I said, with the analytical columns, typically we want to replace the column anyway because there's some other issues that are going on where it's really not feasible to just replace the inlet frit. But for column hardware replacement, we will open the column, we will replace the inlet frit, and we will ensure that the CSP is not damaged. That's extremely important, especially if you go over pressure, like I showed with the voids. Sometimes you will end up creating voids as a result of that. And if you do, then that is where the next two services come into play, either column reconditioning or column repacking. So if you did create a void in your column, we would actually go to the column repack then. We would go and we would remove any of the damaged CSP. We would add in new CSP up to the amount that it needs to be for a quality column. We'll repack it and QC it and send it back to you essentially as a brand new column. If you have some kind of an adsorbed sample on there, or there's some other chromatography issues that are going on, we can take it through our column regeneration process or recondition process. Very similar to repack, but we will take it through our regeneration sequence first, make sure that there isn't any analyte that's stuck on there that we can't help get off. And then again, if it needs to be repacked, we will take it into the next step then and do the repack. And one not necessarily related to a column that has died perhaps, or a column that needs some reworking, we can actually do column resizing. So we have a lot of cases where SFC, we see this a lot actually, folks have older 10 cm columns that perhaps they used for HPLC that are no longer applicable. We can actually take those larger columns in. We will resize them down to smaller usable columns for you, and we will send them back as in a size that you might be able to use now in your newer applications. And the point of all these really is they cost less than purchasing a new column. And like I said, it's added value to hopefully extend the column life a little bit longer to get more out of your initial investment. So the last couple things that I'll point out here are instruction manuals. A lot of what I talked about, especially with solvent compatibility, sample solvent compatibility, things like that, are all discussed in our instruction manuals. So we stopped sending them out with the columns, but we have them all available electronically online. So if you go to our homepage, chiraltech.com/USA, over to the right-hand side, you will see this quick links box, and there is an instruction manuals link, which will take you to all of the instruction manuals that we have for all of our CSPs. And if you can't find one on there, email us and we will send it to you. But in those instruction manuals, you will find some very useful information. This is a sample from our immobilized 3-micron stationary phases. You will find such things like operating instructions, the typical flow rates, and the recommended temperature ranges. You will also find suggested starting conditions for your screening. So these are your normal phase conditions here, your hexane IPA, hexane ethanol, and these are your extended range forbidden solvents that should never ever be used on your coated phases. So your MTBE, THF, and your DCM mobile phases. You will also find things like the suggested additives. I talked about these already, but other things for your basic additives like EDA or BA, and your acidic additives, as well as the suggested percentages that you should stay below. And then you'll also find some useful column care and maintenance, most of which I discussed earlier, but perhaps there's something additional that might help you in storing your columns and, again, protecting their lifetime. So in summary, the major causes of column failure can pretty much be summarized into 3 major points. These are the same for most chromatography columns, achiral, chiral, the same for HPLC columns as well as SFC columns. The major issues are column or inlet fouling. That can be avoided by the use of inline filters or guard columns, but without a doubt, making sure that you have good sample cleanup. Bed compression or void formation. So making sure that you are operating at low or at least reasonable flow rates as kind of outlined in the instruction manuals, and avoiding things like mechanical or thermal shock. And then lastly, chemical attack or modifications, whether it be memory effect or column history, or chemical attack as a result of using an inappropriate pH range or the using of the restricted solvents on the coated phases. So those are the major points today. I will end here with a few email addresses for you that you might find interesting. Questions@cti.dicel.com is where you can contact us if you have any general chromatography issues related to method development or anything related to this presentation today. Tracy Hartledge, who is the host for this webinar today, as well as myself, in case you have questions about this presentation or other chromatography or column questions. I also monitor the questions email address. So either way, I might end up answering your question for you. And then lastly, we have one more upcoming webinar this year on October 30th. The topic is to be determined at the moment, but we welcome your feedback as to potential subject matters on that. And with that, I will pass the mic back to Tracy. And I again thank you all for your attention today.
Thank you, Dr. Umstead, for a very informative presentation, and thanks to all of you for joining us today. I'd like to also thank the technical support team for answering questions. We hope you enjoyed this presentation, and please stay tuned for our next webinar coming in October. Bye-bye.